All right, so here we got just one critical number. V is equal to plus or minus square root 5. So what we're going to do next is we're going to draw the derivative number line. And when we draw the derivative number line, we want to think about it for the specific domain that we have. So if there is a domain restriction, we want to make sure that we put that on our derivative number line. So again, usually we just start with negative to positive infinity, but if there's any sort of domain restriction, we want to make sure that that gets on our derivative number line. So here, for this example, we went through this, but we found that there was no domain restriction, that the domain was all real numbers. So we are good to go here. We can include all real numbers, and then we'll just put down the negative square root 5 and the positive square root 5. Now, where are we going to plug this in? We are going to plug in right before we set the numerator and denominator equal to 0. And we are plugging into the derivative, again, right before we set numerator, denominator equal to 0. So that derivative looked like, and let me flip back here really quick. Get my lined paper so it's not all over the place, okay? So my derivative looked like 21v squared minus 105 over v squared plus 5 quantity squared. Now, we have three intervals. My first interval, the square root of negative 5 is around like 2 point something. Basically, what you can do is you can just anything that is roughly past 2.23 is good to go. So if I'm ever uncertain, I'll always like plug in some really off the wall number like negative 100, but here I'll plug in negative 4. And one thing that I want to really point out is by now we're all kind of done with plugging in numbers. In this denominator, you have your b squared, and anytime you have something squared, that is always going to be positive. So with the quotient rule especially, because of that b squared, usually that denominator is positive and you don't need to sit there and like plug in the negative 4. So keep that in mind. Like, yes, I can plug in the negative 4, or I can notice that, it's b squared, anything squared is going to be positive. So then it really just boils down to what is that numerator quantity, and that is a positive. So we have a positive over a positive telling us that this first interval is positive. And because we're plugging into that first derivative, that is telling us that we're increasing. Then we look for negative square root 5 to square root 5. So maybe plugging in 0. Again, the denominator is that b squared. I know that the denominator will be positive. And then plugging in here, I get a negative. So that middle will be negative. And then that's going to tell us that we're going down the hill, decreasing. And then plugging in maybe like 7 for the last interval. Again, the b squared is positive, and I get that the numerator will evaluate out to a positive. So that positive is going to tell us that we're going up the hill. So when you're looking at this, what you would say is that you are increasing from negative infinity to negative square root 5 union the other positive interval of square root 5 to infinity. We are decreasing from negative square root 5 to square root 5. We have a relative max at negative square root 5 comma the y coordinate, and a relative min at positive square root 5 comma the y coordinate. Now keep in mind, to find those y coordinates, we are going to plug into the original function. So again, when you're looking at the coordinate, the point that you're trying to find, you need to go back to that original function, and I keep referring to the wrong original function, but this function was negative 21v over v squared plus 5. All right, now I want to go through this because we do have square roots, and that's going to provide a little bit more challenge here. So if I plug in negative square root 5, I will have negative 21, and for the v, negative square root 5 over the v squared, negative square root 5 squared plus 5. Now these radicals, you really can't do too much with them. So in the numerator here, when I have negative times negative, that's going to give us a positive 21 square root 5 over, and then in the denominator, I have negative squared, so that gives us a positive, and then the square root squared will give us a positive 5, and then plus 5. So that gives us 10 in the denominator. So the relative max point will happen at 21 square root 5 over 10. And you'll do the same thing for the relative min point where you have square root 5. You're going to have negative 21 times the square root 5 over square root 5 squared plus 5. And that will give us negative 21 square root 5 over the square root square cancel plus 5. And so that gives us 10. So this becomes negative 21 square root 5 over 10.